So let me just start with the normal distribution. Okay? When we say normal distribution, we know that it's a beautiful bell shape, and then it's only one peak, where there's no two peaks. So in statistical term, we're gonna say, oh, it's a symmetrical distribution, and then it's a V model. Okay? And then the normal distribution can be specified by two things. One is mean, and the other one is standard deviation. So we can call them as a parameter. Okay? So if you have information about the parameter of normal distribution, you can specify the normal distribution. Okay? And the first element in the parameters is the mean, and mean is related to the location of the distribution. Okay? And standard deviation controls the spreadness of the distribution. Okay? So we're gonna see these two things later. And then also one thing you should know about the normal distribution is that all normal distribution follows the 68, 95, 99.7 rules. Okay? Also, we're gonna study that today. Before I start the normal distribution thing, I wanna introduce some notation. Okay? So you're gonna see a lot that notation in the statistics course, and that capital N stands for definitely normal distribution, and then there's a parenthesis, and then I'm gonna put a comma there. First element, first blank in that parenthesis, we use mu to represent the mean of the distribution, and then we're gonna use sigma to represent the standard deviation of the normal distribution. Okay, so we're going to using this notation to refer the some specific normal distribution. So let's say, hey, I want to work on normal 0, 1. That means I'm considering. I'm thinking about the normal distribution whose mean is 0 and the standard deviation is 1. Okay. So, as I said, that the mean is related to the normal location of the distribution. So this is the example. So we have two plots of normal distribution. Black line represents the normal distribution whose mean is 0 and standard deviation is 1. And then red line represents the normal distribution whose mean is 2 and standard deviation is 1. So what is the difference between these two? They have same standard deviation, but different mean, right? So since the mean related to the location of the distribution, black one centered at 0, which is its mean, and red one centered at 2, okay, which is the mean of the red one. Okay? So if the mean changed, the distribution itself shifted to red or red. How about we have same mean but different standard deviation? Okay. We have two, black and red. Black is the normal 0, 1, and red is the normal 0, 2. Okay. So we have same mean, so which means two distributions enter the same position, which is 0. Okay. And then since red one has higher standard deviation, we can see that the red is more wider spread. Okay. So the sigma, in that sense, sigma controls the spread of the distribution. Okay. So now the last one in the characteristics of normal distribution was this rule. So 68, 95, 99.7 rule. Okay? It tells you that all the normal distribution follows that specific rule, and that's like approximately, rule of thumb maybe. The first one says that approximately 68% of your data will fall within one standard deviation range from the mean. And the second one, 95% of your observation falls within 2 standard deviation from the mean. And then the last one is 99.7. Okay? So when you see 99.7, it's like 100%, right? So it means that when we think about any normal distribution, if you take the range, 3 standard deviation range from the mean, then that range will capture almost all of your data. Okay? So let me maybe be more specific. I want to pick just one normal distribution, one special normal distribution among many other normal distributions. I want to pick the basic. I want to pick the normal distribution whose mean is 0 and 1. And we call that specific normal distribution as the standard normal distribution. Okay? So we are working on this one, right? Normal 0, 1. So if I draw the picture of the standard normal distribution, I could like this. Okay? It's a bell shape, center that's 0, and then one standard deviation is 1, right? If I take the range of -1 from 1 to 1, if I take this one, what percent of the data, of your data, will fall within that range? It will be 16, right? And same thing, if I pick the -2, it will be 95, right? So now my question is, if I change the range into, let's say, I want to pick the range from 0 to 2. Okay? So what percent of your data will fall within that range?
95%.
95?
Oh wait, what? Wait, what'd you say?
0?
Oh,
Two.
half of that. Half of it.
Half of that will be
47.5.
okay. So what I asked is like, what is the percentage corresponding to this range, this area? And then our answer is 47.5. And by calculating that, you guys implicitly just divide the 2 of 95%. And can you tell me why can we do that? Yep.
Because it's symmetric.
Symmetric, yep. Symmetric means, so when we think about the range from -2 to 2, we know that it will be 95%. And then since the normal distribution is symmetrical, which means this half and this half will be the same, so this one should be corresponding to 47.5%. Okay? If I take the range from -1 to 2, what percentage will be? You don't need to calculate the exact number, but can you tell me how would you get the number? Like percentage corresponding to from -1 to 2.
It would be 47.5 plus 34%, so like
47.
81.5.
What was the last one? 30 what?
34
34.
after 68.
Mhm.
34.
So maybe instead of so let me just draw this one and that one. So our goal is to find the probability or percentage which corresponding to this area, but instead of just calculating the whole thing at one time, what I want to do, I want to divide that into 2 parts, right? And then this right-hand side, we just calculated 47.5%, right? Which is half of the 95. And when you think about the left-hand side, that part, corresponds to the half of the 68%, okay, which is 34%. So if you sum them up, you can get the corresponding proportion, right? Okay, so my last follow-up question. When I think about the range, or maybe if I just be more tricky, do you think IQR is IQR? When you think about IQR and 2, which one is larger?
Are you asking when the standard deviation is 2, so the wider normal distribution?
Yeah, when we are working on the standard normal distribution, and then in standard normal distribution, if you think about IQR, that is larger or less than 2?
Greater than 2.
Greater than 2. Why?
Because the 25th percentile would be between -2 and -1, and the 75th percentile would be between 1 and 2.
Mm-hmm.
So if it's less than -1 up to greater than 1, that would be more than 2 already.
Okay, let me just follow up your opinion. So when we think about the IQR, naturally you should think about Q3 and Q1, right? Right? Because IQR is Q3 minus Q1, and when you think about these two, maybe I can convert this one into the range from Q1, Q2, right? And this 2, maybe convert this 2 into the range like -1 and 1. Does it make sense? Okay. And then what we actually did, I know this one captured the 68%, right? How about the rest of that? So I'm asking, what is the percentage corresponding to outside of that range? It will be 32%. This one plus this one. Because I know this is 68, and then total will be 100, so it will be 32. And then I know it's a symmetrical distribution, so one of them should be 16%, right? Right? Does it make sense? So I know that 16% of the data is less than -1. Okay? So my question, would you put Q1 between -2 to 2 or between -1 to 0? Why?
Because if your 16% is at the -1 mark, then you want to include like 9% more of the data.
Mm-hmm. So when you think about the definition of the first Q, 25% of your data should be less than that number, right? But if you put Q1 here, that means this percent should be 25, but doesn't make any sense because we know that this part corresponding to 16, right? So your Q1 should be around here, right? Does it make sense? So how about the Q3? Q3 will be here or here?
Between 0 and 1.
Yep. So here. Okay. So this part should be capture 15, right? 50, right? So when you think about the IQR, it should capture the 50%, right? When you think about the -1 to 1, capture the 60. So this one should be less than 2. Okay? Okay. So that's the rule. And then now I want to add, explain why that this normal 1, 0 is special. Like, why do we call this a standard? Because based on the 68, 95, 99.7 rule, we can calculate the proportion corresponding to some specific range, like -1 to 1. Maybe we already calculate the -1 to 2, right? Based on that rule. But what if I want to calculate it, the percentage, like -0.5 to 0.5. So we cannot calculate this one using the rule, right? But standard normal distribution is so special because we can calculate this one using some table. Okay? People just already calculate every combination of the range in a table, and we call that as a standard normal table. And you can click the link in my website. You can get the standard normal cumulative table, which looks like this. We have a table, and then we have corresponding, like, the graph. Okay? So if you pick the z number here, this table will tell you the corresponding probability or corresponding proportion, right? And let's say, what's the proportion that half of the standard normal distribution? It will be maybe from -infinity to 0. Okay? That's the range, right? You know what I mean? Let me. So if we think about the standard normal distribution, I know it will be centered at 0. And then if I think about this area from -infinity to 0, it will correspond to the 50%, which is 0.5, right? And then that graph corresponds to this one when the z is 0, right? So when you look up the 0.0 in the table, you should see the 0.5, okay? And the table has the columns and rows. So the first table has the negative z value, and the second one has the positive z value. If you look at the first column, it has 0.0 there. Okay? And then the name of the columns get the 0.00, 0.01, 0.02. It represents the second digit of your z-score. So 0.00 corresponds to the 0.5. Okay? So our question is this. So this standard let me see. Usually capital Z will be used for the variable which follows a standard normal distribution. And then we have an example that, let's say we live in a specific area, and then we record the temperature as maybe Celsius. And then weather records kept for many years indicate that the temperature at 11 a.m. on January 28th follows a standard normal distribution. What proportion of years we can expect the temperature at this time to be less than or equal to minus 1.5 Celsius. How can you calculate that? Yeah.
You go to the z table, and then because it's a standard normal, like the z-score corresponds to the temperature, and so you just go down to like negative 1.50, right? And then
read the
and then read like the little number. thingy.
So maybe I will just write it down. Notation for problem. So I'm gonna use the z for standard normal distribution. So we have some variable which stands for the temperature in that city. We know that this one follows the normal 0, 1. Okay? And then what we need to find is percentage corresponding to that random temperature in that city is less than negative 1.5. Okay? Okay? And to calculate this one, maybe if you draw the picture of the situation, we have standard normal distribution, which is centered at 0, and then we want to find the probability or proportion which corresponding to this area, right? This one, right? Okay. This probability, if you visualize this one using plot, you will get this one. Okay? And then we want to know what is the percentage. And then using the table, you can think this negative 1.5 as a negative 1.50. Okay? So what I want to do, I want to look up the negative 1.5 at the first column, and then since the second digit is 0, I want to select the column corresponding to 0.00. Okay? So if you go to the table, first you want to find the negative 1.5, and then the first column and second column corresponding to 0.00, just I will read the number corresponding to negative 1.5 and then 0.02. I get 0.668. Okay. So this means we have 0.0668. 0.0668, which means 6.68%, right? So I can put 0.0668 or 6.68% there. Okay? So this is the standard normal distribution case, but in our real life, we are usually working on other normal distribution. So for example, I just set up the case where we have already submit our homework score, homework one, and then let's say Professor Wu tells you our homework score distributed as normal distribution, whose mean is like 10 and standard deviation is 2. Okay? So we need to working on like different normal distribution, which is not the standard normal distribution. So in that case, we can convert. So let's say X is our maybe the random homework score, and we know that follows the normal distribution mu and sigma. Instead of working on here, we can convert them into the standard normal scale because in the standard normal scale, we can calculate all the probability using the table, right? So to convert this one, we're gonna use some specific formula, which is called standardization formula. Okay. So if you're using this formula, you can convert this number into the standard normal scale. Okay. So maybe we can just try to understand how does it work with a concrete example. Okay. So, as I said, let's assume our professor tells you our homework score distributed follows the normal distribution 10-2. Okay? This is your information, and what you want to figure out is question 2. Okay? So we already know there are 75 students in this classroom, and then what you want to do, you want to figure out how many people got the homework score, which is below your homework score. And then, so we know that the normal distribution 10-2 is our homework score distribution, and then you went to the icon, you check your homework score as 12. Okay? So you know your homework score is 12, and then you want to figure out how many students has the homework score, which is below than your homework score. What did you do? How can you find that?
You need to convert it using scores, and then you go to the table and get percentage, and you know how many total kids there are. So you can
So to figure out the number of the students who got the homework score lower than yours, first you need to figure out is what percentage of the class got the homework score lower than yours. Okay. So if I write it down, the thing that I want to calculate is this. So I know that, let's say this is homework score. X follows the 10, 2. I know this information. And then what I want to calculate is this one. Proportion corresponding to some random homework score is less than 12. Okay? This is my goal. And if I visualize this one using plot, I would say I would draw this. So 12, 10, and then one standard deviation is 2, right? And then this x is less than 12 will be corresponding to this, right? And then I want to know what percentage corresponds to that, right? And we cannot directly calculate the probability in a normal 10-2 scale. But if I convert this one into standard normal scale, then I can calculate the probability using the table, right? So what I want to do, I want to convert, so this is 12, right? I want to convert these two numbers into the standard normal scale, okay? So first, if I convert, so I want to convert these two into the standard normal scale using standardization formula, which is z is equal to mu divided by sigma, okay? So if you convert 10 into the normal scale and standard normal scale, what number will you get? Do that again.
1.
1. Can you tell me why?
It's 12
So-
minus 2, or 12 minus 10 is 2 divided by 2 is 1.
Oh, no, I mean, so that's the case where you want to convert 12 into. So, what you did is plug this number into the formula, right? So, you plug this one into here, so you have 12 here, and minus mu is the mean, so mu is 10, and then divide by standard deviation is 2, then you will get 1 as a z-score, right? That means if you plug in this 12 into the formula, you'll get z. That means you convert this number into the standard normal scale, and you will get 1 here. So this is converted into this one. And that doesn't make sense because 12 is the mu plus 1 sigma in this normal 10-2, right? And when you think about the 1 here, that's the mean plus 1 sigma in the standard normal distribution, right? Okay. So in that sense, if you convert this 10 into the normal scale, it should be
0.
0. Why? Because if you plug in 10 here, you will get 0. So you will get 0 here. And that also doesn't make sense because this is the mean of the distribution. If you convert this one into the standard normal scale, it should be the mean of the standard normal distribution, right? So I know if I convert these two, I will get 0 and 1. Okay? So, and our goal is to find the probability which corresponding to this area, which means this area also converted as this area, right? So that means I can put 1 here. And then if I calculate this probability, so now if I calculate this probability, I can use it as this probability, right? Now, since I convert this one into the standard normal case, now I can calculate this one using standard normal table, right? How? I can just find the 1, 0, 0. Okay? So, in a table, if you go to the 1, 0 here, and then find the 0, 0, then we got 0.8413. Okay? So I have 0.8413 as the probability that random homework score in a standard normal scale is less than 1. And I can use this number. So in here, so I can put the same number here, 0.8413. Okay? Which means now we know that this one corresponds to 84%, around 84%. Does it make sense? Okay. And then what? Now I know that, oh, there are 84% of the class that did more than my homework score. And I know total number was 75 people in this class. So if I multiply by 0.48, actually 13, I will get the actual number, number of the students whose homework score is less than 12. And if you calculate this one, you will get, I think, 64, around 64. Okay? So I actually put all the process in my website. So if you click that and that, you can see what I did. Okay. So to recap, first I just write it down what I want to calculate, and then this one was not in the standard normal scale. So I want to convert this one into standard normal scale using the standard deviation formula. And then once I convert that into the standard normal scale, I can use z table to calculate the probability. And then if I can use this one as this value, so I just use that number, multiply to the 75. So I got 64, which means about 64 students will get the homework score, which is lower than 12. Okay. So my question is, let's just think about the people who have the homework scores which are between 10 and 12. How many people will get the homework score between 10 and 12?
Thirty-four
34% of the class. Right? Because so now we are thinking about the probability or proportion which corresponds to between 10 and 12, right? And if you visualize this one using plot, now we're gonna just erase this part, and then we're just only considering from 10 to 12, right? This part. But we don't need to, and then we can convert that, and then we can find the probability of this one here, but we don't need to do it. We don't need to redo all the thing because we know the standard normal and the normal distribution is symmetrical. So if I take the mean of that, it should take the 50%, half of the distribution, right? And we already know this thing, the whole range takes the 84%. So if you subtract the half, which is 0.5, you will get the probability corresponding to this one, right? Which is this time 0.3413, right? And then same thing, since we already know 75 people there, 0.3413 will give you, I guess, 26. Okay. Even if you have like decimal point there, you should make it as an integer because we have only integer number for the number of people, right? Okay, my last one. So this is a little bit tricky, but I bet this must be in your exam, okay? So now your professor told you that you have made a top 10 and top 8% of the classroom based on your homework score, okay? And then, can you guess your homework score then?
Yeah.
Yep. That's why I put the example there, exercise there. But how? Actually, I'm gonna give you just 2 minutes to think about the situation and then how did you figure it out, because we have 7 minutes. So. Just just make sure you can solve this one without seeing the answer. Okay? And then when you think about the situation now, instead of having the information in the original scale, what professor gave you is the information in the standard normal scale. Because she said that you made a top 8%, right? Which means when you think about the distribution of the classroom, how many percentage below your score? It will be 92%, right? So which means you have like information in the standard normal scale, and then you want to convert that into the normal scale, original scale, right? Your former score scale. What is the score? 12.8. Let me see. So, I'm gonna start in here. So this is our standard normal scale, normal distribution. And then, I don't know which number, but based on what professor said, I think I know there are 92% of the class is less below my score, and then I made the top 8%, right? So if I find the z-score is corresponding to 0.92, then I can convert this number into my original scale, right? So how can I find the z which is corresponding to 92%? We're gonna use the same standard normal distribution table, but like opposite way. So now what I want to do, I want to find the number which is corresponding to 92%, which is 0.92. So among these numbers, I can find here. So this is 0.9207, and this is like 0.9192. So this is like more closer to 0.92, right? So I'm gonna pick this one. And that means, since we have 0.92, it means that z-score, which is 1.41, corresponds to the 92%. So what we figured out is 0.14 is the z-score. Okay? And then how would you convert that into the normal scale?
Just put it back in the same equation.
Mm-hmm. So to convert this one, we're going to use this one again, but now this is z, not the x, right? So what I have to put is 1.41 here, and then we know everything about the mean and standard deviation. So we don't have to just multiply by 2 to the both side, then that will cancel. So x will be 2 multiplied by 1.41 plus 10. Okay. Then you will get 12.82. Does it make sense? Okay. So if you convert this 1.41 into our original scale, you will get 12.82. Right? So I also put the answer. So you can check out the stuff that I put on my website, and then I figured out that many of you will have some trouble to understand this. So what I actually did, I just recorded this lecture, and then I'll put somewhere in my website, this one, so that you can rewatch. Okay. Okay, I'm done today. You guys can go.